This video is about piecewise functions. A piecewise function is a function that actually has more than one piece to it. So the function might not be one continuous thing, but might be several different pieces of the graph. For this first example, this piecewise defined function is the linear equation y equals 3x plus 1, but only if x is greater than 0. So if we were going to graph that piecewise function, and I know that it's going to cross the y-axis at 1, and then I will count my slope up 3 and over 1, I would get the line that looks like this. Now notice I only drew it to the right of 0, and I'm actually going to make this an open circle here because it's not equal to 0 at that place. The second piece to this is minus x plus 2, but it is only that if x is less than or equal to 0. So we're going to take that piece, I'm going to do it in a different color. That piece is going to cross the y-axis at 2, so 0, 2, and it'll have a negative slope, down 1 over 1, down 1 over 1. I'm going to go up 1, back 1 so that I can see it a little better. And notice that this solid dot is included in the graph, whereas this open circle is not. So it is still a function. It will still pass the vertical line test, so this might be the only place right here at the origin or on the y-axis that it might not, but you'll notice that it's solid where the red dot is and open where the black is. So it is still a function. Now if I wanted to find a function value, for example, I have this piecewise defined function and I wanted to find the function value at 4, what I need to do is ask myself, is 4 greater than 0, or is it less than or equal to 0? And since it's greater than 0, we will plug it into the 3x plus 1, and we'll get 13. If I wanted to find f of negative 1, for example, then negative 1 is less than 0, less than or equal to 0, so that will be negative of the negative 1 plus 2, or 3, and you can see that value right here. So let's do one more example. Let's do one where I have maybe 3 pieces. So I'm going to make this f of x equals x squared if x is greater than or equal to negative 1. This is going to be the value of 2 if x is less than negative 1 and greater than negative 3, and it will be x plus 3 if x is less than negative 3, less than or equal to negative 3. So let's do this kind of in reverse order. If I wanted to know a function value, for example, the function value at 5, then I would notice that 5 is in this region, greater than or equal to negative 1, and so I would plug my 5 in to the first piece and get 25. If I wanted to know the function value at 0, well, 0 is in here. Oh, sorry, 0 is not in there. 0 is in the first one as well, so let's change that. Let's go f of negative 2. Negative 2 is in this region from negative 3 to negative 1, and that function value is 2. And then let's do one more. If I wanted to find, say, the function value at negative 5, well, negative 5 is less than negative 3, so we would plug it into the third piece and get negative 2. So I could continue to choose values, in these regions, for example, x and f of x for this first one, and just choose values that are bigger than negative 1. In that case, I would get 1, 0, 1, and 4. You may also know that that's a parabola. And we'll graph that. So negative 1, 1, 0, 0, 1, 1, and 2, 4. And we're going to get kind of a half of a parabola, right? Anything greater than this negative 1 kind of division line. And then it's going to be 2, y equals 2, for anything between minus 3 and 1. So we'll do minus 3, minus 2, and minus 1. And the function value is always 2. Notice it just says less than, so we're going to have open circles here and here. And then for our third piece, I'm going to choose only values that are less than or equal to negative 3. So I'll do negative 3, negative 4, and negative 5. And if I add 3, I'm going to get 0, negative 1, and negative 2. So negative 3, 0. It's inclusive because of this equal to bar right here. And negative 4, negative 1, negative 5, negative 2. And it will look like this. So this particular graph has 3 different pieces, and again, you'll notice that it does pass the vertical line test. What I sometimes see is graphs that look like this, which means that probably one of your graphs is on the wrong side, because this would not pass the vertical line test and therefore would not be a function. So make sure that you're checking your intervals, your domains. Okay? Hopefully that helped. Talk to you later.